we're going to use some algebraic approaches today to find these limits. So the first one that we always want to try is direct substitution. So that's just taking the value that x is approaching and plugging it in. Sometimes you plug it in, you get an answer like 5 and you're done. Right? Sometimes you may have to use memorized forms. You may not have these memorized yet, but we'll use them pretty often and hopefully you'll get it all together. So one graph that you kind of need to have in your head is the graph of sine of x over x. We only talked about this one day so far, but we'll talk more about it. So it's on the x and y axis. It kind of goes up and down, but towards the middle, it comes up, and then there's a hole in the graph right there. I'm not drawing it great because it's small, and then back down. So that hole occurs at the point 0, 1. That's what I would like for you to have in your brain. The other one we graphed several times yesterday. You have the absolute value of x over x. You have to remember what that one was like. We did 3 different ones on the front of the worksheet.
It was like it's 2 horizontal lines.
Yeah. So it's at a horizontal line at -1, and then an open circle at 0, open circle at 0, horizontal line at +1. Now it can switch. So like if you have a number minus x, that 1 and -1 are switched. But for the most part, that's what it's going to look like. 1 and -1. A lot of the times today, we're going to factor, simplify, substitute. Okay. And we're going to learn some algebraic manipulation methods. The one we're going to talk about today is called the Rationalizing Method. And then you can also use tables and graphs. We've already talked about that. We won't necessarily do those very much today. Okay, so let's go to the top right corner. If you take a positive number and you divide it by 0, that is the equivalent to infinity. And infinity is not a finite number. It's not a defined number. So saying it's undefined is okay. But if you take a positive number and divide it by something really, really close to 0, it's going to make it huge. What if that k is negative? What do you think you get with negative? Right? So if you are using direct substitution and you get 0 over 0 or infinity over infinity, that's indeterminate form. And that means that you should be able to do something algebraically and find the limit. So when you see 0 over 0 or infinity over infinity, you can keep working to find the limit. So what if you take a number and you divide it by the biggest number in the world? What do you think you get? So take your calculator and do 1 divided by 999999999. What y'all get? 1 to the negative 15, so 0.000000. So that's really 0. All right. And that won't necessarily come into play today, but those are some things that happen over the course of the year. right, we're going to skip those properties until tomorrow. We're going to go down to check for your understanding. So when you guys see these limits today are written like this, the first thing I would do is direct substitution. So take what x is approaching, plug it in. You get the square root of 4 or just 2. Super easy. Alright, the next one isn't quite as easy. So you want to take 1 and plug it in. Do you guys remember the handshake? You remember doing it. Do you remember what each finger was?
Are we doing degrees or
Radians.
radians? Radians.
So 0, pi over 6.
Pi over 4.
Good.
Pi over 3. Pi over 2.
Nice. Okay. And then if we're finding the cosine of an angle, do you remember? Square root of the top over 2. Right, so we use our pi over 3 finger. We do the square root of the top over 2. That's 1/2. All right, if we were doing sine, square root of bottom over 2. Did y'all remember tangent?
Square root of the top and square root of the bottom.
Perfect. So square root of the bottom over the square root of the top.
For A, when it's square root of 4, would it be like plus or minus 2? Or just for question A?
Oh, no, because it has that symbol means the principal square root, so it only means the positive.
Okay.
That's a good point, though. And don't forget that on the handshake, like if you have 5 pi over 6, that's still the pi over 6 finger. You just have to move it to a different quadrant, second quadrant. All right, let's look at C. So this time, when I put -2 into the denominator, what do I get? You can do that really fast.
0.
0. All right, so this is one that we're going to have, it's either going to be does not exist or we're going to have some work to do. So when I put -2 into the numerator, it looks like I get 4 plus 8 minus 12, which is 0. Okay. So indeterminate form means we need to do something algebraically to figure it out. When it's a function like this, a rational function, we're going to want to factor the numerator and denominator. Well, the denominator won't factor in this case, so factor the numerator. Then our x plus 2 should cancel out. Now, I like for you guys to keep writing limit. I know it's annoying, but keep writing limit until you actually find it. All right, so we haven't done anything with that -2 yet since we simplified. All right, so now.
Pardon the interruption. Hayden Holick and Anna Rondolini, come to the main office, please.
So now we can take that -2 and put it in for x. And we get that the limit is -8. Now, on a multiple choice, it doesn't really matter what your work looks like. But on the free response part of the AP test, if your work doesn't make sense, like if you just lose a limit, they might take a point off. So I always try to remind you, keep writing limit until you actually find it. Are you okay on that? Okay. The next one's a little harder to factor. But Well, if I plug in -2 in the denominator, I definitely get 0. And same thing in the numerator. Alright, so we're going to have to factor the sum of cubes. So for the sum and difference of cubes, you have a small set of parentheses and a big. So you find each root, find each cube root, and bring it down in the small set. And then you square the first one, change the sign, multiply them together, square the second one. Okay, and then this works out nice, because now x plus 2's will cancel. Separating limit, I haven't actually found it yet. So now I'm ready to plug in -2. So it looks like we get 4 plus 4 plus 4, 4. We're going to do a couple more. So this one, we actually could factor it. It would be super weird though. So we're going to do the rationalizing method. So on this one, when I plug in 4 in the numerator, I get 0. 4 in the denominator also gets 0. So when you have problems that look like this, to use the rationalizing method, you're going to need a square root, which this one has one. And so what you do is you multiply top and bottom by the conjugate of, sometimes it is in the numerator, sometimes it is in the denominator. So we're going to say of the expression with a root. Okay. So what is the conjugate of 2 minus the square root of x? Right, and then one more note. Don't, okay, no, let's not say that, sorry. Only multiply out the conjugates. So you don't want to multiply 4 minus x times 2 plus the square root of x. Like, don't multiply that out. It won't help you in any way. Right, so leave those as factors. But your conjugates, you can multiply, and there's a shortcut, so you can just do 2 times 2. And then the negative square root of x times the square root of x is negative. So the reason you don't want to multiply out the top of this one is because now we have this factor, these factors that will cancel. This is exactly what we wanted to happen. If we had multiplied it out, we wouldn't have seen that. Okay, so this is equal to the limit as x approaches 4 of 2 plus the square root of x. So now we can go ahead and plug that 4 in for x. get 2 plus 2, which is 4. Okay, so look at all those steps. See if there's somewhere that you're not quite sure what happened. The next one, there's a typo. Okay, the next one, it should be the limit as x approaches 0. I messed up. I did it. Okay, so always try direct substitution first. So I put in 0, I definitely get 0 in the denominator. So I'll also get 0 in the numerator. And so when you're looking at it, thinking about what to do, notice that there are radicals. So we're going to do the rationalizing method. This time, your roots are in the numerator. And it's fine. It doesn't matter where they are. We still use the conjugate of the side that has the roots. So it's going to be the square root of x plus 5 plus the square root of 5. Okay, so remember, you do multiply the conjugates. You don't multiply these. Can you guys simplify that down for me, please? So as soon as that x cancels in the denominator, we can plug in 0 because now we won't have 0 in the denominator. So we get 1 over the square root of 5 plus the square root of 5, or 1 over 2 square roots of 5. I know in algebra and in pre-cal, we wouldn't leave a radical in the denominator. In calculus, we don't care. We just leave it. It's fine. You technically, if it was free response, could leave it like this one. So on the AP exam, you don't have to simplify free response questions. No multiple choice, they will be simplified, but free response, leave it. Okay, so what questions do you guys have? Good? Okay, algebra is the best. All right, let me give you guys your assignment. It's out of the book. And if you have a pencil, I am perfectly fine with you circling the problems you're going to do, because sometimes when people do every other even, they get off and end up doing the wrong questions. So on 6 through 22, I want you to do every other even. And then 28, 30, 34. And then 46 through 56,